Hey guys, welcome back to IC Chris, where it's never too late to have an IC moment. Today's video we'll be looking at question 9 from the 2021 May-June Maths Paper 1 past paper. It is a calculus question, so enjoy the video. I just want to remind you about the live Q&A session I'll be doing on the 11th of May 2022. Okay, that's this coming Wednesday. So just a reminder, you will have to be subscribed to the channel to ask any questions, and that will be around 4 o'clock in the afternoon. It will be recorded and uploaded thereafter. So let's jump into today's video. Okay, let's have a look at question 9. Okay, so question 9 is asking us to use calculus in order to solve some properties or finding missing values of a cubic function. Okay, so question 9.1 over there says determine the coordinates A and B. Okay, so looking at the graph over there, you should notice that A and B are turning points. Okay, so I've stated here that A and B are turning points, so you should be thinking of the derivative of f equals to 0. Okay, why do we do that? Because we know that the derivative equals gradient, and at a turning point, okay, when we have either a turning point like this or like this, when we have a flat line, the gradient equals 0. Okay, so we're going to find the derivative of f of x. So f prime of x is going to be 3 times 2 equals 6x. 3 minus 1 is 2. Plus 2 times 3 gives you 6x again. Now 2 minus 1 gives you 1. And then we have minus 12 there. Okay, and that needs to equal to 0. So what I'm going to do is divide out by 6. So I'm going to have x squared plus x minus 2 equals 0. So therefore I'll have the following brackets. You'll have x plus 2 and x minus 1. Okay, now we're not done. Okay, even though if we solve this out we'll get x equals negative 2 or x equals 1. Okay, we're not finished yet because I want the coordinate, which means we need the y values. Okay, so now we take these values and we plug them back into f of x. So we need f of negative 2, okay, which will be for a, because a is sitting on the left of my y-axis. So that is then, if you plug that in, you're going to have 2 negative 2 squared cubed, plus 3 negative 2 squared minus 12 negative 2. Okay, and then if you work all that out, you should get a value of 20. So a's coordinate is then going to be negative 2 and 20. And then for b, we look for f of 1, which should give you negative 7 if you plug that into your calculator. So therefore b is then going to be 1 and negative 7. Okay, now let's have a look at 9.2. It says for which values of f or for which values of x will f be concave up. Okay, so the minute you hear the word concavity, concave up, concave down, you should be thinking of the second derivative. Now for concave up, we need the second derivative greater than 0, and for concave down, we need the second derivative less than 0. Okay, second derivative of a cubic function is a straight line, so we need to find where is a straight line greater than 0 or above the x-axis. Okay, and if it was concave down, then we're looking for the straight line which is then below the x-axis. Okay, so let's have a look here. We want f double prime. Now we know that f prime of x equals to 6x squared. Okay, let's see, plus 6x minus 12. So if you take the second derivative of that, we're going to get the following. So 2 times 6 is going to be 12x, and then this is going to be plus 6, and we need that greater than 0. So now we just solve the inequality. So let's see, we're going to have 12x must be greater than negative a half, which means that x must be giving the answer away too quickly. Okay, so 12x must be greater than negative 6, so therefore x must be greater than negative a half. Okay, and if you then look at the graph over there, you can see it makes sense that for all values above negative a half, we have concaved up. Okay, so concaved up looks like that. And then concave down would then be the other way. Okay, now 9.3 says determine the equation of the tangent line of f 2f at 2 and 4. Okay, so remember tangent's gradient is just f the derivative at the point given. Okay, so if that's my function and I want the tangent line there, okay, all I need to do is take that x-axis or x value and plug it into my function. Okay, the derivative of my function, sorry. So we have the derivative already. That's 6x squared plus 6x minus 12. Okay, now we need to find f prime of 2, which is then 2 squared plus 6 times 2 minus 12. Okay, and if you plug that into your calculator, you should get a value of 24. Okay, so this is your gradient. This is equal to m. Now we just choose y equals to mx plus c. Okay, and they've given us a coordinate of 2 and 4, so we can use that to now find the equation. So we'll have y1 or y minus y1 equals mx minus x1. Okay, so then we have y minus 4 equals 24 x minus 2. Okay, so now if you solve this out, you'll get an equation of y equals to 24x minus 44. Okay, and that's the equation of your tangent line. Okay, so that's how we go about doing this question. Okay, if you guys did find today's video helpful regarding the calculus section of the past paper, please leave a thumbs up on the video. It does help me a lot. I just want to say thank you so much for all the support that you guys have shown towards the channel. I didn't think it would take off this quickly. It's really awesome to see how many people are partaking and enjoying the videos. If you have any comments or questions, please leave them down in the comment section below and I'll get back to them as soon as I can. And remember, it's never too late to have an OSE moment.